And then if you have questions while I'm talking, just either you can raise your hand, you can unmute, or you can just type into the chat. I have the chat here on the side that I can see. But I found that starting with the flow rate questions is a good starting point because, like I said, everything else is review. The flow rate is going to be the things that are new. So I've already gone through these. This will be the fourth time going through the 130 for the last from Tuesday and then today on Thursday. So so if I say I said this already, just keep in mind that meant it's in regards to the fact that I did say this already, but maybe not to you guys. All right. So I always like to start off with the example. Where is it? Okay, this one with the Ringer's lactate. So first of all, let me clear out some of these things here. Clean this up a little bit. I'm going to rewrite all this anyways. All right. So the first thing you need to know about if it's your first time looking at the flow rate questions, you saw that, maybe got a little bit apprehensive, just know that all flow rate is a way to measure a volume being dispensed over time. And it's very much similar to like driving your car, right? Miles per hour. It's just some sort of measurement, in this instance volume, over some period of time. The standard flow rate is going to be milliliters per hour. And you'll see that a lot. A lot of times your questions will even say, calculate the flow rate in milliliters per hour. There's a subcategory of flow rate called the drop rate. And the drop rate is measured in drops per minute. And the abbreviation for drops is GTT. If you're wondering why it isn't DR, DR is the abbreviation for drams. Drams are an apothecary unit, and if you have a bottle of perfume at home, you can actually look at it, and it usually will say drams. That's really the only place I've ever seen it, like in real life, other than talking about it in apothecary terms, in like the pharmacy tech program or some old nursing textbooks and things like that. So sometimes where these go and give students a little bit of a problem is you're looking for something to like multiply, divide, try and just set up some sort of a problem, but there really is no problem. Really, all you're doing is you're taking the volume they give you, 375 milliliters, putting it over the time they give you, 3 hours, and then you reduce it. And you reduce it, 3 goes into 375, 125 times. And so your final answer is just 125 milliliters per hour. So there's no multiplication. Technically, there's division, but you don't need to worry about, calculating, milligrams per milliliter, trying to figure out how much to order. This is just what you're programming into the infusion pump. So for practice, I'm going to have you guys do this one down here, but I'm going to change the variables. Okay. Let's make this 1.25 liters. And then we're going to say over, let's do 15 hours. So go ahead and take your time. See if you can come up with the milliliters per hour for the question I just typed up here. And then just type it into the chat. If you're uncertain about your answer and don't want to necessarily make it public, just send it to me as a direct message. And I promise I won't call you out on it. And go ahead and I'll give you a minute or two to solve that. And then I will be right back. Some of the answers. Some of you are really close, but keep in mind, that when we're looking at these types of things, you need to make sure that you keep in mind our rounding rules. Now, you may not like the way this looks, but you should have gotten an answer of 83.3 milliliters per hour. Basically, we take 1,250 milliliters divided by 15, and then you get 83.3333333. I think in reality, because I had this conversation earlier today, in reality, you're probably going to program 83 milliliters per hour in the infusion pump in an actual clinical setting. But because we're taking the math test and they want you to practice your rounding, that's why you are rounding it to the nearest tenth, because it is it's a volume, milliliters. We can measure milliliters to the tenth. So just remember, if you get an answer that has a tenth in it and it's milliliters, to go ahead and include that in your answer. No. Yeah, no, I did not. I wrote 1.25 liters. So just make sure when you are, and you'll be able to see this when you go back to the actual test. This is uploaded for you in real time. And then I know there might be a little bit of a delay, so that's why I try and give you a few seconds. So just wait till I'm making my changes. If I don't know what kind of lag there is, because everything just seems normal to me, but I know that there's a lag. There has to be. Okay. So let's look at another version where we're going to now look at what if it gives it to me in minutes. So if they give us a time in minutes, you need to recall how to convert minutes to hours. Okay. So in this example, number 17, I said that a patient, I'm just going to get rid of this number here. A patient must receive a tube feeding of Ensure 120 milliliters in 90 minutes. Calculate the flow rate in milliliters per hour. Now, most students, when they see that, they say automatically, oh, 90 minutes, 1.5 hours. Perfect. You made that conversion exactly right. However, it may not always be as easy as converting it to minutes to hours, like as quickly as 90 minutes is, or even like 30 minutes would be 0.5 hours. So what I'm going to do is I'm going to change this up. So don't do anything yet. Hold on. I'm going to change this to, let's make this 250 milliliters. Actually, let's make it more realistic. So let's say 480 milliliters. And then we're going to say in 24 minutes. And I want to know, if I was going to do that as an infusion, what would I plug into the infusion pump? So go ahead and practice that. Let me know what you would get in milliliters per hour if my starting point is 480 milliliters and it's over 24 minutes. So let's take a look. I'm seeing a lot of you are writing 1200 milliliters per hour. So let me just confirm that. That sounds right to me. So all I'm going to do is I'm going to take the milliliters, 480 times 60, which gives me 28,800. And then I'm going to divide by 24. And then like you, I got 1,200 milliliters per hour. So if you, in a hypothetical situation, you're setting somebody up to this tube feeding and you're setting that up and that's how they want you to administer it, my guess is they wouldn't want you necessarily to give them 2 cups of Ensure that quickly. But now you know how to set that up. And you might be sitting there going like, oh my God, 1,200 milliliters per hour. That sounds like ridiculous. But remember, that's 2 cups, right? 2 cups of a drink in 24 minutes. That's actually not unrealistic. Most of us can pound a 20-ounce, thing of water in like 30 seconds if you're thirsty enough, right? you take a 20-ounce bottle of water, that's equivalent to 600 milliliters, and you have no problem putting that away in a matter of seconds, let alone minutes. Again, if you're thirsty. If you're just sipping on it and drinking like a normal person, you probably aren't just crushing it like that. All right. So we discussed flow rates if they're given to you as milliliters per hour. We discussed flow rates if they give it to you as milliliters per minute. The next scenario is, what about a time situation? So let's say they ask you, how long will this infusion take? Okay. So in this scenario, in 18, the given scenario, it tells us we have a total IV solution of 500 milliliters, and it's infusing at a rate of 125 milliliters per hour. So we know the rate. What we're trying to figure out is how long before the bag runs out. Okay. So what I would recommend doing is I'm going to do dimensional analysis where I'm trying to get rid of the milliliters. I'm looking for my time, 125 milliliters, 1 hour. If you're doing ordered over available for this, you'd be doing 500 milliliters over 125 milliliters times 1, and that's then you're doing that correctly. So 500 divided by 125 is going to be a time of 4 hours. So I'm going to give you another scenario, and this time we're going to change the variables up. So don't use 750 and 150 just yet. Let's I'm gonna also do this as liters. So let's say it's 1.05 liters, and it's infusing at let's say 175 milliliters per hour. Now, for your answer, I want it just in hours. So you might have a decimal answer. Just go ahead and give the decimal answer. All right, so I'm seeing 6 hours as an answer. So let me confirm that. I'm always surprised when these things work out exactly because I'm thinking that we're going to get. So I'm going to take 1,050 mLs divided by 175 ml, and yeah, you get 6 hours. So I was hoping it was going to be like some other number, but that's okay. So 6 hours. Now, if you're taking a test and you answer it and you get another number like six, let's say you get 6.6 hours or 6.34 hours or something like that. That's actually what I wrote down here. So if we get a different time, so I'll go through a different scenario and to give you like some alternatives just in case you might see questions like this. And then I'll try and give you an easier way to kind of figure this stuff out. But let's say they are asking you not only how long will it run, but they want to be specific. They might ask you, how long will it run, hours and minutes. They might even ask you if it started at 8:35 in the morning, what time would it end? And so I'm going to go through I'm going to go through a scenario that would include all that kind of information. So let's say you do your calculation, you have your volume over time, your milliliters per hour, and you get an answer. And let's say this time it's, let's say you get 6.82 hours. Okay. So some weird number. All right. So we know it's 6 hours. That's not a problem. So we know that it's 6 hours. But that 0.82, what do we do with that? So what you're going to do is, this is 0.82 hour. All we're going to do is convert hour to minute. And you know, and I know, that 1 hour is the equivalent of 60 minutes. And so what we're going to do then is take that 0.82 times 60, and I'm going to get an answer of 49.2. So we can round that answer, and that's going to be 49 minutes. If you want to be very specific, you could then multiply that 0.2 by 60. And then 0.2 times 60 is 12. So you could say 6 hours, 49 minutes, and 12 seconds is the exact time that it'll end. But I don't think anyone's going to ask you that. Just Dr. Rad being annoying as far as that's concerned. All right, so 6 hours, 49 minutes. So let's say you know now, and now you know how to convert that decimal to an actual time. Let's say they tell you something like, okay, well, the infusion starts at, let's say, 7:42 a.m. And the question is, when will it end? So the next thing is, go ahead and do your calculations, and I'm purposely making this a little bit difficult. What would 6 hours and 49 minutes be from 7 hours and 42 minutes? And just so we know, that's a time. So that is a 4, not a 9. There you go. That looks more like a 4. All right. So see what you come up with. I'm going to give you just a few moments to look at that. And good. You guys are crushing it as far as getting your answers. So if it starts at 7:42 a.m., 6 hours and 49 minutes later is going to be 2:31 p.m. Or if you did it and you used military time, that's perfectly fine too. They may even prefer to use military time. I don't know that definitively, which is why I'm just putting it in standard time.
I didn't get quite on that. Like 2:31. You said like it started at 7:42 a.m.
Mm-hmm.
and it takes
So
6 hours.
and 49 minutes.
Uh,
So 6 hours from 7:42 would be 1:42 p.m.
yeah. Oh, okay. Uh-huh.
And then you got to add the 49 minutes.
Oh, okay. I got it now.
Okay. Okay. So we did basic volume over time, milliliters per hour. We did a variation of milliliters per minute, converting that to milliliters per hour. Then we did how long the infusion will run for, and then gave you a couple different scenarios associated with that. The next thing to look at is drop factor. Okay. So when we talk about drop rate, earlier I mentioned like you would put 83, like if you got an answer of 83.333333 milliliters per hour, you would round to the nearest tenth. Again, in the CCAC math bubble, that would be your answer. In reality, you may not be able to program that into the infusion pump, so you'd probably just do the nearest whole number. On the math test, when it comes to the drop factor and when it comes to drops, you cannot give somebody a partial drop, just like you can't give somebody a partial capsule, right? You can't give somebody 0.4 of a capsule, even though you might be like, oh, I could just cut that in half. You can't cut it in half because the capsule has little pellets on the inside that the medication is dispensed, and you can't assume that you're giving that patient 50% of what's in there. Are you going to be close? Probably, but from what I understand, you're not supposed to do it that way. A tablet that's scored can be cut in half. And so that is okay to do. But when it comes to drops and when it comes to capsules, we can't give somebody a partial drop or a partial capsule. So, saying that, let's look at this question here that has to do with the drop factor. So, I already wrote, and I'll rewrite these things so we can do it together. I already wrote the formula that typically I would recommend following for drop rate. You need two pieces of information. You need flow rate and you need the drop factor. The flow rate will be given to you. The drop factor will be given to you. The flow rate may not be given to you in obvious terms, like it may not say 125 milliliters per hour, but it will tell you 75 milliliters, 25 minutes. That's the rate you're looking for. Now, I did add down here and I said milliliters per minute. It's as a reminder that it's a reminder that you do want minutes in your flow rate. Meaning, if you get 125 milliliters per hour, what I would do with that information is I would convert the hours to minutes right there off the bat. So I would say 125 ml over 60 minutes. That would be the shortened way I would do that particular type of problem. Or you can do the dimensional analysis way where you're converting hours to minutes, which is dividing by 60. So the drop factor will be given to you. So in this example, it's in the label. So it's that 15 drops per milliliter. That is the factor or those are the units for the drop factor, is how many drops the tubing will allow that will equal a milliliter. So that can vary. So it could be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. It could be any number of drops per milliliter. Just depends on the diameter of the tubing. So let's solve this particular problem using the information that's there. Now, if you do dimensional analysis, you probably won't have a problem with doing this question. It would probably come off as being relatively straightforward, and that's perfectly fine. It doesn't have to be any more difficult than that. But I'm going to take the volume they give me over the time they give me, and then I'm going to multiply by the drop factor they give me, which is 15. And then I know that I can cancel out milliliters. I'm left with what I'm looking for, drops per minute, and I get 45 drops per minute. Let's look at a separate example, and I'll change the variables and see if you can get the answer. So give me a second. Let me change these here. I'm going to make this a drop factor of 5. It's going to be 250 ml, and we're going to make this in, let's make it 1.5 hours. So the question is, what would I program into my infusion pump in drops per minute, keeping in mind that we are going to round to the nearest whole drop. So go ahead and see what you get, and then and I'll just mute here. All right, so I'm seeing a couple answers coming in, and we've got 3 different answers so far. So first of all, remember what I said before I muted myself. You can't give somebody a partial drop. You have to give them a whole drop, okay? And so I can't give them a decimal drop ever. It's a whole drop, okay? So what you should have answered for this question, your answer should actually be 14 drops per minute. Now, because some of the answers are all over the place, let me show you my work. I'm going to start off with my flow rate, 250 milliliters. And then it says 1.5 hours. We've seen that before. We know that that's also equivalent to 90 minutes. Then I'm going to multiply by my drop factor. 5 drops per milliliter. And when I do that, I'm going to get 13.8, and it's just repeating. 8. We can't give somebody a 0.8 of a thing there, of a drop. So I'm going to round it to the nearest whole drop of 14 drops per minute. I'm just looking to see. Hold on. Oh, okay. All right. So it is good. Just make sure when you are when you're reading through your questions, take your time. So if you're using the wrong variables, obviously, that's going to create some problems. So if you used like the 15 for the drop factor instead of the 5, just keep in mind there's different drop factors. So you want to make sure you're paying attention to the drop factor that's listed as opposed to what was on the previous label or something like that. And I should also add that in the event that you get asked a question and the drop factor is not listed, so this would be like on ATI, they'll usually say, or NCLEX, they'll say something like microtubing. Microtubing is 60, as in 60 minutes in an hour, 60 drops per milliliter. So microtubing, the drop factor for a microtubing is 60 drops per milliliter. I don't think you'll have to worry about that, but just letting you know in case you do see something like that, you'll hopefully now know what that is. Okay, yeah. So before I go to the reconstitution question, let's just jump up here to the replacement volume, the intake output question. So the secret to this question, it's not really a secret, it's just a matter of arranging the components here for doing the fluid replacement type question. So this is what I do when I think of and answer this type of question. I look at this, and then I'll give you, I haven't done this since I haven't done this yet, where I do a sample question or separate sample question. So I'm going to go ahead and do that now. I'm going to copy this, create a separate question here, and then change the variables. I'll come right back to that, so don't worry. So the how I'm arranging this question, because this is typically what you're going to see is a question like this, is I'm going to take whatever the patient actually voided, so actual urine out, I'm going to put that over my expected urine out. So in this scenario, my actual urine output was 500 milliliters. My expected urine output is 125 milliliters. Then I'm going to multiply it by the replacement volume. Some people do like a ratio proportion. That's actually where this kind of formula came from. It was just rearranging some of the variables and trying to be consistent. But you always want to put your actual output on the top and your expected output on the bottom. And then also use some, like, think about the thing. If every 125 milliliters that they void, I need to replace with 40, and then they actually voided 500, you know that it's going to be a number that's probably going to be 4 or 5 times the replacement volume of 40 milliliters, right? Because they actually voided out 500, and you're supposed to give them 40 for every 125 they lose. And that's how, that's just another way to kind of wrap your head around a question like this. So if I'm solving this, I'm going to take 500 milliliters. I'm going to take 125 milliliters times my replacement volume, and then I'm going to get 160 milliliters of replacement is what I'm calculating for. So let me give you an alternative scenario. So let's say for every 60 milliliters of output, we're going to replace with 75 milliliters. And in the last 4 hours, you know what? Yeah, that's fine. In the last 4 hours, they actually voided out 80. Actually, I am just going to say 40 milliliters. I'm going to make it so it looks like they're not voiding as much as they should be. Okay. So these are smaller values. Go ahead and take a moment, apply the what I showed you in the first part of 6 and see if you can answer that question, and go ahead and put your answer into the chat. And good, I'm already seeing some of these answers coming in, so I'm just going to double check what everyone wrote. 40 divided by 60 times 75, and I also get a fluid replacement volume of 50 milliliters, which should make sense, right? So I'm actually going to replace it with less than 75 because they voided less than the actual expected output of 60. So you're doing that right if you got 50. I don't think that you're going to see a scenario like that, but just so you know, like, you're doing it right, math wise. The other thing I will say is some students have gotten hung up on the 4 hours. The 4 hours is really just when you are, like, you're collecting or you're checking how much was voided, probably in their catheter, and then you're adding more water via the peg tubing. Okay, so obviously we're talking most likely of a patient that's unconscious, they have a catheter in, they have a peg tube in, and you are just making sure that they're staying properly hydrated. And so that's what this all comes down to, right? So when you see that, don't get hung up on the 4 hours. That's probably just an indication of when they're checking the urine output, as well as when they're checking the fluid replacement needs. All right, so the one other thing I'll share with you before I just kind of let it open for the next like 15 minutes or so, I just want to introduce you. I don't think you're going to see this question on this test, but you might see it in the future, on a future test, and that is it's a reconstitution question with a label that's a little bit different than the typical labels that you're used to seeing. And what I mean by that is if I go to, let's look at some of our labels here. Like if I go here to this morphine injection. So this is a morphine injection. Injections tell you they're liquids. They're going to get injected, and we're going to be measuring out milliliters. So I need to know what the strength is per milliliter. So this tells me 15 milligrams per milliliter. And so I can do my calculations based off of the fact that I know what the concentration is. So if it's intramuscular, that tells you they're looking for milliliters, we can look at the label and get that information. So if for every milliliter that is injected, it's 15 milligrams, and then we can just do our order over available and not have a problem. What this reconstitution is very similar to any kind of liquid-based medication, whether it's injectable or an oral suspension. The difference is some of these labels are just a little bit different than what you're used to looking at. So unlike that morphine label I just showed you, you'll see here that what stands out is that it says 500 milligrams. It doesn't say anything about milliliters. And that's your clue that you're dealing with this type of reconstitution question that you might need to look further for the information you're looking for. So where are you going to look? You look to the side, and in the side, you're going to be looking at the directions. And so this is where you have to kind of dive into the label and do a little bit more legwork than just looking at the strength as it's listed on there. So your clues are it's intramuscular. They don't give you the milliliters on the label. That's your clue that you need to look at the side label and then look at the instructions. And so when you're looking at the instructions, what you're looking for is where it says, and I have a little red dot there, it says for intramuscular administration, which is what we're doing. Add 2 milliliters of sterile water for injection, because right now it's a powdered form, so we need to add water to get to that. So that's not the volume we're looking for. We're going to shake it up, and then we're going to get an approximate total volume of 2.2 milliliters. Still not necessarily what we're looking for. What we're looking for is what's in parentheses here, that 225 milligrams per milliliter. That is the strength or the concentration of ANSEF, or this medication, once it has been mixed with water. And then now that you know that information, now you can go ahead and solve your problem, right? You take your order of 375 gram or 0.375 grams. I converted it to milligrams, divided by my available, which is 225 milligrams, multiply by 1 milliliter. I get 1.666666666, and we round that answer to 1.7 milliliters. All right, so I'll give you a few minutes. Go ahead and look over, your practice test. If there's some questions or question types you want worked through, just either type it into the chat or unmute yourself. I'm muting myself, but I'm here. So just let me know what questions you have.
I have a question on the I don't remember what question it is, but it's maybe like 18, I think. I don't know.
Okay.
Right, no, right there. Scroll back down. The one where it says it's like the chart.
Oh, this right here?
Yeah, 21 and
Okay.
22.
All right, go ahead. Tell me your question.
I just don't get how you would answer it. Like, so when it says to choose the highest strength, or he just choosing the biggest number, like I didn't know if he would solve it first and then choose whatever answer was larger, or just choose the one that was bigger after it. Like, I don't.
Okay. So you could go through and answer each question, but you'd be wasting some time because all you need to look for is which one is the strongest concentration, right? So which one has more milligrams per milliliter? And then so for number 21, you have three options. You can give them the 5 milligrams per milliliter strength, the 10 milligrams per milliliter, or what I have highlighted there, the 20 milligrams per milliliter, right? Because 20 is greater than 10 and it's also greater than 5. So just that's what you would use, is that choice. Same thing can be said about the number 22, the Pfizer pen. You're using the strongest concentration. You look at you ignore the milliliters diluent added, because that's just telling the pharmacy how much water to add to the powder. And then when it tells you specifically units per milliliter, that tells you what the concentration is. That's the same thing as Dilantin, 125 milligrams per 5 ml. It's telling you, but instead of milligrams, now it's units per ml. And so you look at which one has the strongest concentration: 250,000 units per milliliter, 500,000 units per milliliter, or actually 1 million units per milliliter. So it's the one that is the highest, is the strongest concentration. Go ahead.
Okay, 1 second. So what about 25, the one that takes up the whole page? That one's like really confusing for me.
The incentive year one.
It has a bunch of information and a chart with it. Bolus patient with heparin 80 units kg.
Oh, what semester are you in?
Second semester.
Heparin's not on your test.
It says the 220, 230. Is that the third semester? Oh
That's
my
third
God.
semester. Yeah.
Bruh. Okay, my bad.
That's okay. We don't need to cross that bridge just yet.
Dr. Red, I have one question.
Uh-huh.
When we're converting pounds to kilogram, can we round up, or we have to write the exact number?
So when you're converting pounds to kilograms, like in a like at the beginning,
Yes, it's the fifth question.
yeah, you always round to the nearest tenth. So if you, for 131 pounds, divide by 2.2,
It's
and
gonna
you're gonna get
9.5.
correct.
So we have to write 60 kilogram.
Nope, round to the nearest tenth.
So 59?
59.5.
Okay.
Yeah. So when you are doing, when it comes, the times that you're rounding, you want to make sure you're rounding to the nearest tenth. So you're going to be rounding any time or most times that you're converting pounds to kilograms,
Okay.
or if you're doing any of the other converting household measurements like pounds, ounces, teaspoons, tablespoons, and you're going to the metric system, you may need to round. And if you do, you round to the nearest tenth. When you're doing a conversion like metric to metric, so like this example here, like 75 milligrams, when you get an answer of 0.075 grams, that is your answer. You do not round metric to metric conversions. You do round when you're going with between different units, though.
All right. Thank you.
You're welcome. Yeah, and you may not always need to round. Sometimes you'll get something like, for somebody that's 176 pounds, 176 divided by 2.2 is exactly 80, and that's what you'd write as your answer. So you do not need to change that or do anything else like that.
Okay. Thank you.
You're welcome. For a label problem, remember, all you're doing is making sure you're looking at your label, okay, and making sure that you're getting the information you need to get from, and also reading what the question is asking you for. So for like this question here, this is Dilantin. The order is 250 milligrams by mouth. It specifically says how many teaspoons, but you might see another version of this question where it says how many milliliters would you give, okay? So how many teaspoons, and then we can see what we have available is the 125 milligram per 5 ml. And then this is where any of these label problems, you can always just use your order over available. So my order is 250 mg. My available is 125 milligrams. The one thing that most students forget is to multiply by the quantity. So the quantity in this example is 5 milliliters, right? So if I was looking for how many milliliters, I'd multiply this number by 5 milliliters. But what does 5 milliliters also equal? 5 milliliters also equals 1 teaspoon. Okay? And so you would get an answer of 2 teaspoons. The reason I'm calling this out is because, especially in the 110 test, the thing that was commonly missed was everyone knows how to do ordered over available, but everyone forgets that the whole equation is order over available times quantity. Don't forget to multiply by your quantity. Sometimes it's 1 milliliter, sometimes it's 5 milliliters, sometimes it's 2 milliliters, sometimes it's 15 milliliters. And in fact, as an example, or another example, here's an example. Well, this is basically the same thing, 125.5. I thought I had another example. I guess I don't. If you go back and look at like the 110 review, there was a question about potassium chloride, and potassium chloride is available as it's like 20 milligrams per 15 ml. So you got to keep in mind that quantity when you are solving some of these questions. So keep in mind order over available times quantity. Don't forget that that quantity might be different. So just make sure you're reading the label appropriately. All right. So 15 is right there. So a couple takeaways. Remember, when you're marking your syringe, first of all, what I wrote up here where it says solution and amount to be drawn up first and correct total medication level. If you're on a paper test, I highly recommend that you just write what you know is the right answer. where people miss, or where students are missing this question, is just with marking the syringe. And it's not that you're necessarily marking it incorrectly. You're just, well, you are marking it incorrectly. And it's just because of the nuance associated with how they want you to mark it. So I'm going to try and show you that. But I always make sure I write, okay, solution amount to be drawn up first. So it's 10 units, regular insulin first. You know that regular is always drawn first. You've even heard the analogy clear before cloudy, but I would even just say it sounds to me like only regular is clear. So it's always regular first. So if you're mixing insulin, regular insulin first, and then whatever else second. It's usually humulin N or NPH. I think they might even all be the same thing. And then you want to make sure you can add those two numbers together, right? 10 units plus 40 units is 50 units. Now, where the trick comes in is, and I don't want to say trick, but where people miss is, first of all, they forget to mark or choose the correct syringe because it tells you to select A or B. So we selected B. And then what they're really testing you on is, can you accurately mark the syringe? And you did it a couple times already in the context of this practice with the TubeX. You made marks on the TubeX. So you're doing the same thing with this. So what you want to make sure, and what I always do, is I put my mark at the total mark first, and I indicate total. Okay, so total is 50. Then, to correctly mark where the regular insulin is first, because you drew it up first, technically, or I should say not technically, but hypothetically, the regular insulin is going to be closest to the plunger side, which is why I mark the regular at 40, because 50 minus 10 is 40. Then I add, as an extra piece of information, I add that little line between the two marks, indicating that that's where the regular insulin exists. The NPH is located between 0 and 40. So just as an aside, in the when you first open up the shared OneDrive link or the OnePoint, I have a PDF and a Word document associated with this as well. And I'm going to share that. Hold on one second. So you can see what I'm seeing. And so this came from a textbook. And the textbook shows you when you're mixing two types of insulin, what they're looking for you to show is that the 10 units of regular insulin is going to be closest to the plunger, for lack of a better term, and then the non-regular insulin is going to be closest to the needle. Okay. Any of you who have done this or have even looked at videos of doing the insulin, you know that it just all mixes together once it's drawn up. So you're not wrong in thinking that. But what they're just wanting you to demonstrate is essentially what I'm showing you here. They want to mark at the total. For this one, it would be 40. And then the regular would be at 30, even though your instinct is to put it at 10 because it says 10. But you're thinking final product, not necessarily what it was. And then that's your textbook in case there's anybody telling you you did it wrong or that I showed you wrong. It's coming right from one of the textbooks that they use for drug calculation. All right, so that's our review for today. If you have any additional questions, please reach out to me. You can watch the previous reviews that I've done. They are available for you on YouTube. I already uploaded what I did on Tuesday, and then I will upload the ones that I did today later this evening. And if I don't hear from you, good luck on your test. I hope you do well. And I'll talk to you again later in the semester.
Thank you.
Thank you so
Thanks.
much.
You're welcome.